Hmm. Hi, I'm Andrew, and I'll be explaining how to do a t-test in Google Sheets. So a t-test is a statistical test that helps you find out if there is a statistically significant difference between two groups. For example, perhaps a control group and a treatment group. And it only would work for comparing one group to another group. So if you have more groups, you need to use a different kind of test. But in this example, we'll just be showing a t-test. So as you can see here, we have some values for uh, condition 1 and condition 2 over time. Exact units don't matter in this case, but just as an observation, you might think, oh, the values in condition 1 seem to be pretty different from the values in condition 2. Like, there's some big numbers in here, and these numbers seem to be a little bit smaller. But we need like a scientific number that we can use to justify that. Scientists don't just, look at the data and make a conclusion without doing any statistical analysis. So it's actually really easy to do the t-test. Doing it by hand requires like a kind of boring formula, but you can just do equal sign t-test and then select your first row. So in this case, you do B2 colon B13. So essentially you just have to get the entire column of data that you're interested in t-testing highlighted in this color, and you just do that by putting the coordinates of the first block or cell and then the coordinates of the last block or cell and putting a colon in between. So for this one, condition 2, you do C2 and then colon and then C13 to grab all the blocks from this column. And then you do comma 2, comma 1, those are just settings for the t-test function. And you put a parentheses to close it off and press enter. So now a number will appear, 0.012. This means that the two conditions are statistically significantly different because scientists, well, oftentimes the p-value cutoff is 0.05, which means that any number less than 0.05 would mean that your results are statistically significantly different. So essentially this means that there's less than a 5% chance that the difference in your results is just due to a coincidence or chance or maybe a bad day or good day. Sometimes scientists will use 0.01, in which case our result wouldn't be statistically significant, but I think that for many purposes 0.05 is perfectly adequate.